Hello. We're going to continue to look at some different ratio problems on the SAT. And apropos, that's the word of the day, apropos of the the previous videos, let's go ahead and just run this down like clockwork. Okay, so let's just start with this problem here. It says, in a certain type of breakfast cereal, the ratio by weight of wheat puffs to, what do you know? What a coincidence. Wheat puffs to marshmallow pieces is 7:2. Okay. Taking that first sentence, let me set that ratio up. That means we have, for every 7 wheat puffs, we have 2 ounces of marshmallows. Okay? And then what we're going to want to do is set that equal to some specific amounts and then cross-multiply and solve. All right. But, boom-ba-dum, we have a problem. It says, if a box of cereal weighs 16 ounces, how many ounces of marshmallow pieces does the box contain? Okay, so here's a couple of things that we know. We want to solve for this, right? We want to figure out how many marshmallow pieces we have. But, in order to do that, we need to match up some number with the ratios that we're given, right? So we would presumably need to know how many wheat puffs we're supposed to have so that we can set that up and do this. So, here's where we have an issue. They didn't tell us how many wheat puffs we had. They just said the entire box weighed 16 ounces. So I can't put this here. I can't say I have 16 ounces of wheat puffs, because I don't. I have 16 ounces of wheat puffs plus some sort of amount of marshmallows. Okay, so what we need to do here is we need to find a total, right? This is an indirect problem, right? We're not given directly a ratio that matches with what the original ratio is, but what we can do is take that original ratio and look at it and say, okay, if I have 7 ounces of wheat puffs for every 2 ounces of marshmallows, that means out of a total of 9 ounces, right, 7 plus 2, out of a total of 9 ounces, I have 7 ounces of wheat puffs, or I could say out of a total of 9 total ounces, I have 2 ounces of marshmallows. Okay? Which of these do we want to use? Well, since we're being asked to find marshmallow pieces, we're going to want to use this one. Okay? So let's just set this up. So that means we could say for every 9 ounces total of the cereal, we're going to have 2 ounces of marshmallows. Well, then therefore, if we have 16 ounces total, right, that's what they told us, 16 ounces here, how many marshmallows would we have? Well, so just that original, we'll use X to represent the unknown amount of marshmallows, but now we just cross-multiply. That's it. Once you have it set up, it's clockwork. It's simple. It's just going to be that times this, which is, what's that, 2 times 16, that's going to be 32. So 32 is equal to 9x. I feel like I'm going to have to dig the calculator out on this one. Yeah. So that's going to be, okay, we divide both sides by 9, and that gets us to the amount of marshmallows is going to be equal to 32 over 9. Since this is the SAT, decimals are frowned upon. Let's go ahead and just reduce this as much as possible. I think we can divide both. What can I do? Oh, snap. I'm losing my mind here. I don't think we can. I think we have to do 32 over 9. Yeah. Let me see. Let me pull up the calculator. 32 divided by 9. I'm cheating. Yeah, we're probably going to have to. So, okay, so what you could do, looks like 3.5555. So what you could do if this was which it was a free response question because there were no answer choices there. There's 2 ways that you could answer this in the SAT. One would be 32/9. Okay, that would be correct. Or you could write, if this was a calculator problem, you could put 3.5 and you have to round it off, right? So it would be 3.56. Remember, there's only 4 slots that you have on the SAT to enter things in. So it's like 1, 2/4. Yeah. Okay. So either of these would be correct. They don't penalize you, despite what I said earlier. They don't penalize you for putting approximation with a decimal, but I do generally recommend sticking to fractions if you can. It just keeps things a little less weird. But anyway, okay. So enough of that. Let's go ahead and do one more. And then, okay, look at this one for a second. Okay, it says, if cement, gravel, and sand are to be mixed in the ratio of this to this to that, and we have 5 tons of cement, how many tons of the mixture can be made. Well, okay, right there, we're not comparing cement to any, to gravel or to sand. We're comparing it to the total amount. So immediately that means we need to be adding up all this stuff, right, to find the total. So if we have 3 tons of cement and 5 tons of gravel and 7, so that means, and we're dealing with cement here, hopefully you follow this, that means that we have, for every 3 tons of cement, we have a total of 3 plus 5 plus 7, that's 15. 15 total. Okay? So we set that equal to, the thing that we want to know is how many tons of the mixture can be made, so that would match up with this right here, right, the total. So unknown total. And it says we have 5 tons of cement, so we need to match that up with the cement on the top there. Okay, and then boom, we just go from there. We cross multiply. Okay, so that would be 3 times unknown is equal to 15 times 5. What is that? I can do this. 75. 75 total. So then the unknown amount is going to be equal to 75 divided by 3. And that is, of course, equal to 25, and there's our answer. Again, the takeaway here is that all you have to do with ratio problems is first set up your original ratio and then set it equal to the portions that you need to calculate, right? So that's, you know what? I think I'm going to pause here because that's it's more confusing than it probably needs to be. But, okay, so I'm going to save it. I'm going to collect my thoughts. This video is getting long anyway, and I will then try to recapitulate all of that in the next video.